A Stuart S50 slide valve experiment. The slide valve in this engine is slightly too long. This makes the valve timing retarded, which means that steam admission is late. I wonder what happens if I shorten the valve. This engine is part of a really good quality steam plant that I'm building for a customer. The only thing that spoils it is the knocking noise coming from the S50 when it's running. This was the best of the bunch of S50s that was sent to me to build into the plant. And there's no appreciable wear in either the bearings or any other parts, it just makes a knocking noise when it's running. Time to dismantle it and get the valve out to look at it. When I build model steam plants, I always make them serviceable, because you never know when you're going to need to dismantle one. This one's coming apart very quickly and very easily. I don't even need to remove it from the baseboard. I do, however, need to take off the displacement lubricator. I'll do this at a high speed. There it is, out of the way. That means I can get at the two bolts above and below where the lubricator mounts. The steam chest is held in place by 4 studs, one at each corner, and these 2 bolts just hold the cover to the steam chest. With the steam chest cover removed, I can now see what's going on within the steam chest. And as you can see, the valve is not quite right, it's just a little bit too long. It is travelling equidistantly over the ports, but no amount of tweaking of the eccentric is going to put this problem right. The valve needs shortening. What I need to do is accurately mill away the edges of the valve, and for this I'm using a very small milling machine for a very small valve. This is a Proxxon MF70, and it's quite a good machine for its size. It does have its limitations though. Here are some edited clips taken from part 12 of a series I made a while ago. It's called Hogwarts Castle, a 5-inch gauge locomotive, and this is all about the brake blocks. I went up to Blackgates Engineering and bought a piece of brass bar, and this brass bar is 1/4 of an inch thick by 1/2 an inch wide. Then I asked Matt at Blackgates if he would be so kind and roll the piece of bar, using their proper set of bending rollers. The ones at Blackgates Engineering are electrically powered and quite big, because the set of bending rollers that I have are very small. And this is how it turned out. It's really good. What I'm doing here is cutting off the ends, because when you use bending rollers, the very end parts of the bar, or whatever you're rolling, isn't as accurate as the rest. All I'm doing is trimming about 1 inch off each end, and that way what's left is accurate to the diameter of the wheel. The next step is to mark and cut out the brake blocks from this ring. I have a 5-inch gauge model of a 14XX Great Western locomotive, and I featured this model in a video a while back as I rebuilt it. All I had to do was measure the brake blocks on that, then measure and mark some lines on the brass ring, followed by cutting out the individual brake blocks on the bandsaw. And in this clip I'm profiling the edges to the correct shape using my 1-inch belt sander, which is a very useful tool. After just taking the sharp edge off the other side, they all look like this. This is the first time I've used this machine. It's a Proxxon milling machine, and it really is good. I'm amazed at this. Whenever I use milling cutters of this size in my large milling machine, I always break them. But not in this Proxxon milling machine. I'm milling a slot of the same length in every brake block. And look, after I've finished, the cutting tool is still intact. And that's a first for me with this size of milling cutter. And after my miniature milling frenzy, all the blocks have got a nice slot which is exactly the same depth in exactly the same position. What I need to do now is make the part of the brake block that fits into the hanger. The slot in the brake hangers is really not very deep. I will have to shape the end of this piece of brass to fit into the brake hanger. So here you see the principle. I now have a full set of brake blocks with mountings to allow them to be fastened into the hangers. And the next step is to silver solder all the components together. As you've just seen, all the milling of the brake blocks took place in this MF70 machine with a correct milling cutter. But in this episode I used an incorrect, far too long milling cutter. I should have made the effort and gone up to the main workshop for a correct one. But anyway, I decided not to, and I'm using this long milling cutter to trim the edge of the valve, and it's doing the job. Well, at least it was to start with. Look at the shaft of the milling cutter where it goes into the collet chuck. and you will see that it's working loose and it's getting lower and lower and it's no longer cutting. I turned off the machine and decided it would be a good idea to retighten it into the chuck. Once I retightened the collet, it appeared to work fine, but after a while it worked loose again. While the machine is stationary, I'll just show you this highly technical way of making sure the valve is in the correct place before I start to mill the end of it. I'm using the little known wooden toothbrush method. Unfortunately, the job went downhill from here. Once again, the milling cutter, which is very long and vibrates a lot, started to work loose. The milling machine isn't bolted down, by the way, so if you see it moving, it's not a camera fault and it's not a fault with the machine. I removed this long milling cutter from the collet chuck using 2 spanners, and then in its place I fitted this drum sander. Now by rotating the top handle, I can lower the drive system so that the drum sander is in the right place to clean up the edge of this valve. I don't like this particular drum sander. I think it's a Dremel, and the sanding drums always seem to work loose. Having said that, this is not a Dremel sanding drum. Anyway, it settles down to a position where it cuts the valve. My engineering is generally unorthodox, but I don't normally do jobs like this. I thought it would just make a change. Had I have used the milling cutters that I should have used, as shown in the video clip, things would have been much better. But to be honest, watching this drum sander in action, it's removing the metal from the valve at an alarming rate, and it's a good finish. I'm showing this clip of me cleaning up the face of the valve just to remove any burrs. The way the valve is now, I don't think it's going to span the ports fully. I may have another go because I have a few Stuart valves that haven't been machined. The best thing to do is put it back together, connect some compressed air and see what happens. I refitted the steam chest cover to the steam chest and held the entire assembly to the engine with just a couple of studs. And as you can hear, it's running a lot better. It's still powerful, it only knocks when I put a heavy load on the flywheel. Bear in mind it is of course not a new engine and it's done quite a bit of running in its time. I need to give it a proper run, so I replaced all the fixings on the steam chest cover. Here I'm injecting some steam oil into this cylinder. And then, with a bit of help from some Loctite 542, I screw the displacement lubricator back in position. Because the valve is slightly too small now, it opens both ports at the same time, when the valve is exactly at the midpoint on the port face. As you can hear now though, it runs a lot smoother. I really think it should be okay. It's a lot better than it was. And as a reminder, this is what it was like before I shortened the valve. And running at the same speed, this is what it sounds like now, so I think the valve operation is a success. The steam, or compressed air in this case, is being admitted just on top dead centre or maybe slightly after, so it is still retarded from a timing point of view. The plant makes a bit more noise when both of the engines are running. I really think this is about as good as I can get this engine to be. Maybe the throw of the eccentric sheave is not quite as it should be. It easily powers the dynamo and lights the lamps very well. I will see how well it runs when it's in steam, and that should be in the next episode. Stay safe, stay healthy, thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. and by doing that you can find other videos that you may like to watch. And by using the playlists you can actually watch the videos back to back.